Can you see the whiteboard? Okay. So we will see conversion of NFA to DFA. So what happens in NFA and what happens in DFA, you have to know the concept. So in NFA, from one particular state, if you take any input symbol, it can go to multiple states. Okay, or you can just say machine can go to multiple states. But in case of DFA, for every specific input symbol, there will be just one transition state. That means machine can move to just one state for one particular input symbol. But in case of NFA, it's not like that. So to convert NFA to DFA, we have certain like steps, but I will tell you just the easiest method. Okay. So in many different places, you will see different methods. There can be many different algorithms. I'll just show you the easiest one. So what you can do is, for example, we have an NFA which will accept strings with input symbol 0 and 1, in which second last bit is 1. So we need to first design the NFA which will accept string containing second last digit is the 1. That means what? Suppose last two digit means something like this. Okay. So this is the first bit, this is the second bit, least significant bit, then your second least significant bit. We always count binary bits from 0, 1, 2, 3, 4, and so on, right? So this is the first bit and this is the second bit. So what's the condition? Second last bit is 1. So this is the second last bit and it must be a 1. Okay, then in the zeroth position, that means first position, it can be either 0 or it can be either 1. Correct? Last position, it can be anything. It can be 0, it can be 1. Doesn't matter. It can be either 0 or 1. But the second position must be just the 1. Then what can be the in front? Again, in front it can be combination of any 0 and 1. Right? It can be combination of any 0 and 1. Okay, 0 or 1 star, you can say 1 or 0 star. Any combination, it can be 0, 0, 1, 0, 0, 1, 0, 0, 1, 0. It can be also 1, 1, 1, 1, 1, 1, like this. Second bit 1, second bit 1, can be 0, 1, 0, second bit 1, can be 1, 1, 0, 1, 0, second bit, again 1, 1, 0, 1, 1, second bit 1. So last position, it can be either 0 or 1. And in front, it can be combination of any 0 and 1. Okay. So your NFA will look like something. Suppose from the initial state, you are going to one state. Okay. Then Q1. Okay. So I can say this is the second bit, then the last bit can be either 0 or 1, right? Q2 maybe. So what's the minimum string here? Minimum string can be 1 0 or minimum string can be 1 1. Correct? This is the last position. In front, there can be anything. But the smallest string or the smallest string can be either 1 0 or can be 1 1. So this is just satisfying the condition 1 0 or 1 1. It will reach the final state. Now in front, there can be anything, right? Any combinations of 0 and 1. So you can write 0 and 1. Okay, this is the NFA. Now here I didn't mention where it can go for 0 or 1. For Q2 also, I don't have to show where is it going for the alphabet 0 and 1 because NFA allows that configuration, right? So this is the NFA which will accept the binary string in which second last bit is 1. This one is clear? How we constructed the NFA? How we designed the NFA, is it clear? Second last bit 1 means what? सेकंड वाला 1 ही रहेगा, लास्ट वाला पोजीशन में 0 भी हो सकता है 1 भी हो सकता है. So minimum string is 1 0 or 1 1, and in front it can be anything, any combinations of 0 or 1. So I can just make a self loop. It will accept just any combinations of 0 and 1. ये समझ में आया? Okay. Okay. Now अभी ये समझ में आया तो now what you have to do, you just make the transition table from the NFA. Okay, so to convert NFA to DFA, first you just make the transition table. Then again you you have to make another transition table. Okay, let's just first make the transition table for this NFA. Okay, so how we make the transition tables? Basically, it consists of the input alphabets 0 and 1. Here it is, and we have states. Okay, so what are the states here? Q0, Q1, and Q2. Q1 and Q2. Correct? 3 states: Q0, Q1, Q2. Okay, this is the initial state, and this is our final state. Right? So in table also, you can just show initial state with this arrow, and you can show the final state either with the circle, or in some places you might see the star also. Okay, just select one, whichever you want, either star or just make a circle here with the final state. Okay, now how we make transition table? From state Q0, you have to see where is it going for input alphabet 0 and input alphabet 1. Okay, so from Q0, by taking input alphabet 0, it's coming to the same state Q0. Correct? Now from Q0, after taking input symbol 1, it is going to 2 states. One is Q0 and the other is Q1. So you have to write both Q0 and Q1. Got this? From Q0, for input symbol 0, it's coming back to the Q0 again. And for input alphabet 1, it is going to 2 states, Q0 and Q1. So you have to mention the both here. Okay, you have to mention both here. So this one is done for Q0. Now you have to come to Q1. So in Q1, for input symbol 0, it is going to Q2. And for input symbol 1, it is going to Q2. That's it. Now for Q2, it's not going anywhere. It's not taking 0 or 1. So you can just write like this. It's not going anywhere, so no transitions. Okay. So this is the transition state for this NFA. Is this one clear? How we two different person the same question के लिए different diagram हो सकते हैं. Two different person का same question के लिए different diagram हो सकता है in case both NFA or DFA. Very unlikely. Very unlikely. But yes, it is possible sometimes. But it is very unlikely. Yeah. Transition table समझ में आया? From this NFA we constructed this one. Okay, so now we have to make a transition table which will be a transition table from DFA. That means we are going to convert NFA to DFA from the transition table only. Okay, so what we have to do here, we just need to make equivalent transition table for DFA. Okay, just write down. Okay, now this is a bit different. What we have to do here is for every stage we are getting here, we need to evaluate it. Okay, what's the first state here? You cannot directly write Q0, Q1, Q2 here. Okay, for this one, equivalent DFA, you cannot directly write Q0, Q1, Q2. So now what you have to do, you have to just expand each of these states separately for every input symbol, which is 0 and 1 here. So what you have to do, first you start from Q0. Okay, Q0 is the initial state. Here also Q0 is the initial state. So what you will do, first just take the first row, Q0. So for Q0, for 0, where is it going? For 0, it is in Q0 again. Okay, for Q1, where is it? It is in Q0 and Q1. So you got Q0 and Q1. Okay, this is simple. Now from this point, you have to expand each and every state you are getting from here, from this table only. Later you will match it with this one, but you will write the main one from this one. So from this line, you just consider this row first. Q0 is already expanded here, correct? We just expanded Q0. For 0, it is going to Q0, and for 1, it is going to Q0 and Q1. Okay, so this one is done. So next state is what? Q0 and Q1. So you will bring this Q0, Q1 down here. That means now you will evaluate this Q0 and Q1 state. You are considering this as a state here. Okay. Now for Q0 and Q1, you have to see Q0 and Q1. Just think we are checking Q0 and Q1. You have to see where is it going for input symbol 0 and for input 1. So you have to consider the port 1. Port 1 means what? For 0, Q0 is going to Q0 and Q1 is going to Q2. So you have to write Q0 and Q2. Okay. So for Q1, where is it going? For 1, Q0 is going to Q0, Q1, Q0, Q1, and for Q1, it is going to Q2. So just write Q2. Okay, so we have expanded this one. Now you again have to expand each and every one. You have expanded this one, you have expanded this one. So now you will expand this one. So bring this one down here. This state. Now you have to check Q0 and Q2. That means Q0 and Q2. Okay. For Q0 and Q2, where is it going? For Q0, it is going to Q0. And for Q2, it's not going anywhere. It's blank. So just Q0. Now for 1, where is it going? Q0, Q1. For Q2, it's not going anywhere. So it's just blank. Done. This one done. Expanded. Now third is this one. Q0, Q1, Q2. Okay. Now you have to consider all these 3 states. Q0, Q1 and Q2. So for Q0 and Q1 and Q2, if you see this column for 0, it will be Q0 and Q2. For Q0, it is going to Q0. For Q1, it's going to Q2. For Q2, it's not going anywhere. Okay. Now for 1, for Q0, it is going to Q0, Q1. And for Q2, nothing. That's it. Okay. Now you have expanded this one also. Okay. Next is Q0. This one you have already expanded here. Q0, Q1 you have already expanded here. So this is the last transition state. The last one was Q0, Q1, Q2 and we have expanded. So this is the transition table for your equivalent DFA. Is this one clear? How we expanded this transition table from here? Okay, so what you have to do, just start from the initial state Q0, Q0, same. Then you have to expand each of these states. Q0 pehle ho gaya. Next Q0, Q1. You just see where is it going, Q0, Q2. Okay, so this one done. Then for symbol 1, it is going to Q0, Q1 and Q2. So Q0, Q1, Q2. Just we have to follow the direction. Yes, correct. Yes. You have to check it from the transition table also. It will be much easier. So once you have constructed this equivalent DFA transition table, now you have to design the equivalent DFA. So what are the states now? How many states are there for your DFA? 1, 2, 3, 4. So one state is Q0. One state is Q0, Q1. One state is Q0, Q2. And the third, so Q0, Q1, Q2. So 4 states, 4 states. So now you just need to follow the transition step. So this is initial state. Okay. So for Q0, by taking 0, it is coming back to Q0 again. For Q0, for 1, it is going to Q0, Q1. Okay. For Q0, Q1, by taking 0, it is going to Q0, Q2. Okay. Next, for Q0, Q1, for 1, it is going to Q0, Q1 and Q2. Okay. For Q0, Q2, by taking 0, it is going to Q0. Okay. Then for Q0, Q2, for 1, it is going to Q0, Q1. Then from Q0, Q1, Q2, by taking 0, it is going to Q0, Q2. And from here, it is going to Q0, Q1. Okay, so that's it. from Q0 Q1 by taking 1 coming here, by taking 0 it is going to Q0 Q2. Okay, arrow should be here. Okay, arrow should be here. From Q0 and Q1 by taking 0 it is going to Q0 Q2. Okay, and by taking 1 it is going to Q1 Q2. Okay, from Q0 Q2 by taking 0 it is going to Q2, and by taking 1, oh sorry, I made it wrongly. This is not here. 0. And for Q0 0 and 1, it's Q0 Q1. Okay, this is the equivalent DFA. Oh, sorry, I forgot this Q2 here. So here I'll just make the cell. Okay. And this is okay. Q2 from Q0 0 1 Q0 Q1. From Q this one by 0 it is coming to here, by 1 it is going here. For this state, for 0 going to here, for 1 going to here. From this one by 0 it is going there, and by 1 it is coming back to here again. So this is the equivalent here. Okay, is this one clear? So first you make the NFA, then you build the transition table, then for equivalent DFA you have to expand each and every state. Okay, now which one will be the final state? Okay, there should be a final state too, right? So here Q2 is the final state. That means what? All the states which consist of Q2 will be the final state. That means this one will be the final state and this one will be also a final state. So same, this one will be a final state and this one will be a final state. Okay, so first make this transition table, expand each of the states, then you build a DFA. Okay, and initial state will remain initial state and the final state will be all the state which will consist of the final state in the actual NFA. Here Q2 was final state, so यहाँ पे भी जहाँ जहाँ पे Q2 है सब final states हो जाएगा. Okay, so this is the equivalent DFA. Clear? Next class we can do some more examples. Okay, so I'm stop sharing. Give attendance. तुम लोग का अटेंडेंस लेकिन सच्ची में कम होता जा रहा है. मैं कुछ नहीं बोलूंगी. मेंटर्स बोलेंगे आपसे. Okay, I'm ending the meeting now. I have to pack my bags and go to. Okay, thank you.